video we're going to have a look at group 7. It's really a continuation. There's a short video already on the observations when you take a solid halide and react with sulfuric acid, and this video just goes over some of the equations and things that are happening. So when you look at the first reaction there for a solid sample of sodium chloride with sulfuric acid, you can write in the oxidation states. And remember, we saw white misty fumes that we said was the HCl. The oxidation states of chlorine are not changing, they're still -1. The oxidation states of sulfur is not changing, so this is not a redox reaction. You see there that the sulfuric acid is acting to donate a proton, so it is acting as an acid. So no redox reaction occurs. The chloride ion cannot reduce sulfuric acid, so it's a weak reducing agent. Thinking about what you know about group 7 now, you can have a go at the question. You can then check your answer. So we saw there with the solid chloride that there was no redox reaction taking place. However, when we looked at the bromides and the iodides, there was some reduction of the sulfuric acid, so other reactions are taking place. You can either work through now, having watched those videos or done the practical already, work through the equations, making sure that you write all the appropriate observations. So if you want to stop the video and do the bromides and iodides. So firstly, with the iodide and sulfuric acid, steamy white fumes, a non-redox process, an acid-base reaction. I think you just said iodide there, it should be bromide. Yeah, we'll look at the bromide salts first, over that. Then with the bromide ion, you can get the reduction of sulfuric acid to SO2. If you want to have a go at writing all the equations, the half equations and the overall redox reaction, and then you can check your answers. So it's important to remember with the bromide ion, it does start to reduce the sulfuric acid. Make sure you can remember the observations for each of the products formed and then be able to write half equations. The bromide ion reduces the sulfuric acid to SO2 but doesn't go any further, so the bromide ion is acting as a reducing agent, therefore the sulfuric acid must be the oxidizing agent. This is now for the solid iodide. Remember, the iodide was the one that actually reduced sulfuric acid to all of the 3 different things that we saw. So you can again fill in the observations and the half equations. The acid-base reaction occurs first, giving you steamy white fumes of your hydrogen iodide. With the solid iodide, the sulfuric acid is reduced to 3 different products, so you get SO2, the sulfur and the H2S, so you can write equations of observations for all of those. The sulfur dioxide formation, those are the observations and the equations. Again, you can check your answers. And the last set is to produce the H2S. So there are quite a lot of equations covered there, so do practice those. There's more in the exam packs and study packs in order to practice those equations. To make sure you remember the observations, that table earlier, for all the observations for the acid-base reactions and the redox reaction products. So looking there then, that the iodide is the most powerful reducing agent. It will reduce sulfuric acid down to all the 3 products. So the sulfuric acid itself is acting as an oxidizing agent. So just to summarise then, we've been looking at the reducing strength of the solid halides. To make sure you identify whether it's a halide. So a solid halide and the power of that. And as you go down the group, so the iodide was the most powerful reducing agent. Remember, a reducing agent is a substance which donates electrons. The halide ions can act as reducing agents because it can donate electrons in order to form halogens. And the reducing power increases as you go down the group, so the iodide being the most powerful reducing agent. This is because as you go down the group, there are more shells, so there's more shielding. So the attraction between the nucleus and the electron being donated is less, and therefore they're more easily donated. This little table just summarises the redox behaviour of the halogens on the left. So so Cl2, Br2, etc. And the halides that we've just done in this video on the right, so the Cl minus, Br minus, etc. And as you can see, the halogens, the oxidizing strength increases as you go up the group, whereas with the halides, the reducing strength increases as you go down the group. But do make sure when you're answering questions, you're looking at things, whether you're talking about halogens, oxidizing agents, or oxidizing powers, or the halide, the solid halides, and their reducing strength. So the strongest oxidizing agent there is chlorine, F2, and the strongest reducing agent there is iodide, I-.